Hey students, how's it going? I thought I would make a video for you guys just to review how to graph polynomials if you've already got it factored, just so you're ready for that quiz. Okay, so wow, that's incredible. Okay, let's just kind of make one up. So let's say our polynomial is about x minus 2 squared times x plus 4 to the third times x minus 5. That could be our polynomial. So we know that that thing is degree 6. So both tails should go the same direction if we did this right. We don't need to expand it out to figure out what the I don't know why it's doing that. That's pretty weird. I think that's why. Okay. Anyway, we don't need to expand it out to figure out which the end behavior is. We can figure it out just from this. So we know that we need to find the zeros, which we already know, and then say what their multiplicity is. So we know x is 2 is a 0, and its multiplicity 2, so it bounces off because it's even. So that's a bounce. X is negative 4 is a 0. That's of multiplicity 3. So that's odd, so that goes through. And then 5 is a 0. It's multiplicity 1, which is odd, so it goes through. Okay. That pretty much gives us everything we need. Well, we also need to know the y-intercept, and we get that by multiplying all these last numbers to the correct powers together. So a naught, which is the y-intercept, is negative 2 squared times 4 to the third times negative 5. So let's do that with the calculator. So that's going to be a 4 to the okay. So negative 2 squared times 4 to the third then times negative 5. So we're getting negative 1280. All right. So it might help to get a table of values. I know we didn't do that in class, but I'm going to do it tomorrow. Just so that it's helpful to get a few more data points than what we were doing because our graph was pretty distorted. So let's just make a table of values. Let me move that over a little bit. Okay. So x is 0 is when this happened, right? This is associated with x is 0. So let's put them in order. We have negative 4, 0, 2, 5 would be the order to put those in. So I'm going to choose a point to the left of this just for the heck of it. Alright, and then I'll choose a point in between negative 4 and 0. So how about negative 2? Then I'll go to 0. Then I'll choose a point in between 0 and 2, so 1. Then the 2. Then a point in between 2 and 5, so I'll just go 3, 4, and then 5, and then 6. Wow, I already went off the little chart there, but okay. So we can get all these numbers, but we already know a lot of these. We know that this was a 0. Sorry, that one wasn't a 0. The -4 was a 0. 2 is a 0. And 5 is a 0. Alright, and it wouldn't hurt to just fill in the rest of these numbers that I put in. So why don't we just put it in here? So x minus 2, bring this down slightly. X minus 2 times x plus 4 to the third and x minus 5. I'm going to put it in there to check it later anyway, but we'll just go to our table. We want to do -5. Nope, I have to make it so it's this table set. Where is table set? There. I want independent ask. So -5, what does that give us? 490. Then let's just make sure -4 gives us a 0. -2 gives us something. 1, or okay, let's try 0 again. We already figured that out. 1 gives us -500. 2 gives us a 0. 3, 4, 5, 6. Okay. So looking at that data range there, we see that the thing grows really, really rapidly once you get past 5. And we see that the two tails are going both up. We can see a lot from this data set. So let's draw it. Let's go -6 to 6, I guess. That's how we should set up. Or x-axis. And we might as well just put the integers in there. For the y column, I don't think it makes a whole hell of a lot of sense to try to graph that point. It'll dwarf everything else. So I'm just going to go from the lowest number is -2048 and the biggest is 490. So I'm going to go -2500 to 500. Alright, so I know I won't have to go up too high on there. There, I should be able to see what I need to see in that window. Okay. So each one of these little tick marks is 100. It's a pretty good scale on it. Okay, so now let's just plot our zeros. So negative 4, 0. And then, all right, we'll skip that one for now. 2, 0. And 5, 0. So those are our zeros. Now our y-intercept is at negative 1280. So that's about, so there's negative 1100, 1200, 1300. So it's roughly right there. Okay. Now let's just start at the beginning of the table. Negative 5, 490. So that's almost right up at the 500. Negative 4, 0. Negative 2, 896. That's basically negative 900. So that'll be one tick mark below 1,000. So that's at negative 2. Then we did our y-intercept. It's pretty obvious what this thing is doing. So that was at negative, oh, that's not at negative, I put that at negative 3, but it's supposed to be at negative 2. Sorry about that. That looks a little better. Then we already did that one. So 1, negative 500 is exactly here. And then we hit the 0. Then 686, so it bounced off there. So at 3 we go down to 6, it's almost negative 700. Okay. And then at 4 we do negative 2048. So it got way down here. Just past 2,000. So that thing rocketed way down there. It's a very strangely behaved function, but I think with this info we can see what we got to do. We knew it was going to go through here, right? Let's just check to see if that's right. Yeah, through. So keep going through here. Now it suddenly has to go up to here. So it did something wild. It did some pretty wild gyrating in there. It's going to come down here. I don't know how far down that's going to go, but it has to turn around. It bounced off at this one, right? At 2. Yep. So now it has to just really crazy quick grow like that. So it should look something like that when we graph it. So if we go into our window, the x's we have ranging from negative 6 to 6. The y's I have a minimum of negative 2,500 and a maximum of 500. And I was going by hundreds. We should see this. Keep in mind that this viewing window is going to compress things vertically, but more or less we should see that. So it should really drop down rapidly. Okay. Yeah. So we can get a somewhat more accurate graph if we do that. Okay, so it's good to fill out the table a little more. The point is that there are some that you cannot do without. The zeros gotta be there. I want to see all the intercepts is what I'm saying. I want you to graph it. I want you to put the intercepts in there, and then I also want you to put in other points between the intercepts. So if you had 3 x-intercepts and 1 y-intercept, that's 4 points. So put points in between them. right? And then maybe on each side if you can. See what I'm saying? So let's try a different example. Little issue here. Okay. So let's make up a new polynomial function. There's no particular reason why you can't have a constant out front. So let's throw a constant in there. And not all these factors have to be integers. So you could get something like this in there. Let's have an integer one. And then let's have another integer one. Let's do that. So this is still a polynomial. I just have a constant on there. And what's different this time is that there's a non-integer 0 there. But it's still rational. So it shouldn't be a big deal. So setting all those three factors to 0, we're getting these zeros. X is -1/2. That is odd multiplicity, so that's through. X is 2, odd multiplicity, that's through. X is -3, that's even multiplicity, so that is bounce. So what I guess we ought to do is just make a table of values and plot those points to give us our line. Let's just make it kind of long here. Alright, so we're going to need our y-intercept, which is when x is 0, so that'll be in between these two zeros. So this is our lowest one, so I'll put that down here. And then I'll put just an integer after it. And then okay. And then I'll just do the integers until I get to -1/2. How about that? I've got to have -1/2 in there because it's an intercept. Then we'll have our, I don't have to have a point in between the y-intercept and that x-intercept because they're within an integer of each other already. All right, and we're going continue up until we get past 2, so I'll just do 1, 2, 3. That table should be sufficient for what we need to do. So let's change this function to be 2 times 2x plus 1 cubed, and then x minus 2, and then x plus 3 to the 4th. Let's get a table. So let's just start over. So 3, 2, 1, 0, -1/2, -1, -2, -3, -4. And I'll just delete this one. So your choice of numbers here is going to tell me whether or not you understood what I was asking you to do. I want to see these points plotted. That way I know you didn't just plot it in a random window and then copy it off your graphing calculator, because anyone could do that. I want you to see if you can do this. So we know, I haven't looked at that yet, I just know this is a 0. I know this is a 0. And I know this is a 0 if I did things right. And sure enough, they are. Now that is a truly gigantic number, so I'm going to ignore it. I'm just going to say huge. This one's pretty far down there, but I'm going to put it in there because it's an intermediary value. So negative 13,824. Then this one's not so crazy. And then this is 96,216, and then 41,16. Now we have to choose, like if we try to capture the whole thing and all of its wild gyrations, it's gonna look stupid. All right, we have to choose a reasonable range. That's why I'm just totally ignoring this 3, because it's going off to infinity so quickly that, you know, it's a problem. I don't even think I want to be able to see this point necessarily. I just want to know that it goes super negative. So let's see if we can set it up so we can see the other stuff. And this one also is getting really huge at the end. Did we expect this thing to have both tails going to the same direction? Because that's what's happening. This thing should be even degree. So 4, 5, 6, 7, 8. Sure enough, it is. Okay, so things are making sense. I'm also not terribly interested in being able to include that number in the data range of that column. So I'm going to make sure I can see all these numbers in the table. So if I did that, I want to be able to see negative 324. So that's like the lowest number relevant to be looking at. So why don't I just go negative 500 to 500, because I'll see it get big and I'll see it get small, and it'll certainly go down further than that. You see how there's a little bit of an art to this choice? There's not much of an art to choosing x numbers and how to set your x-axis up. That's pretty forced, really. And I'm going to try to make my graphing window look the same as the dimensions of this. This is a 3 by 2 window. So I'm going to try to make my graph look like that just so the check works. Alright, so my biggest x is 3 and the smallest is negative 4. So why don't I just go negative 4 to 4? Okay, so if that is my viewing window, that's like my 3 dimension, so I want to just kind of go not up too much. I want to go up in a 2 to 3 ratio, so about that much down. I'll go a little further. Okay, so like I said, I'm going to do 500, negative 500. And then each of these is 100, right? We should be able to come up with a nice looking graph in that window. Okay, so 2, 0. That's a good starting place. We'll ignore the 1. At 0, we're at negative 324. So that's a quarter more down that way. Alright, and we know it's rocketing downwards. At negative 1/2, we have a 0. And then at negative 1, it gets to about 100. And then at negative 2, it goes up to a little above 200. Then at -3, we're back down on the x-axis. We're getting a bounce there because now it's going crazy high. So we know it bounces there. It looks like what it's doing is something like that. I don't know, it's doing something like, it's probably more like, it doesn't inflect there necessarily, and then this is just going to go like that. It should kind of do that, right? I mean, this thing goes rapidly downwards, and it goes way the heck down here. So let's see, if we set our window up, we should see that. -4 to 4, -500 to 500, going by hundreds. This should look very similar to what I drew. There's even more extreme like this, but that's okay. I'd rather you not do what this thing does. I want you to see that they're converging down to some minimum down here. It's just you'd have to zoom really far out, and you'd lose all this detail in here if you did. If you insisted on capturing that minimum down there, you wouldn't even be able to see this maximum. Okay. It's clear that there's a really, really low minimum down there, just from the understanding of that. But I'm not looking for you to have a perfect looking graph here. What I want to see is, can you find the intercepts, and do you have the right behavior at those intercepts? Through, bounce, and make sure it goes through the y-intercept. Okay, so that's probably good enough for this video. We'll do this in class, so have a good day.